All right. Well, I know a lot of you had UC application workshop this morning, so you were missing the notes today. So I will try to do the notes here quickly for you. Some of you may be a little confused as we go, and that's okay. Others of you might love what we're doing. That's good too. And some of you might not even look at them. Okay, that would be bad. So the note sheet, hopefully you downloaded it already off the website. And what we're going to do is this one, it's not in OneNote, it is actually on my old Smartboard software. So instead of typing it all over on OneNote again, I'm just going to do it on the Smartboard software. Okay, if I break into rhyme, I'll go cat in the hat on you. But here is the note sheet. Okay, it should say 3.2, focus on the design of an experiment. And the top part of the worksheet, there are just a lot of different fill in the blank, one word or two word answers. So we'll go through these and fill them in. But the experiment that we're going to, the focus of the design of the experiment, this is the section kind of like in Unit 2 where we had one whole page that included, on the test, that had the correlation where you had A through G that you had to answer. There is a question or a page on the test that covers all of this. So you'll have to go through and you have to do the diagram for the experiment and then explain out all of the steps. So this is probably the most important set of notes. We did not finish in class today, and I will only go on this video as far as we went in class today. So it'll be about all the front page and half of the back page. That's all we did today. So an experiment is very important. The experiment is going to control a lot of the things that we do, and that's the purpose of an experiment, is to control lurking variables. But an experiment is when we do something to someone or something in order to observe the response. Okay, we have to impose something and see what happens. So what we're doing is we're manipulating the x variable to see what happens to the y variable. Okay, so we're not going to just by chance check these out. We are actually going to impose something. We're going to impose a treatment. That's further down. Okay. But those which the experiment is done to are called the experimental units. Okay, it might be people, it might be plants, it might be cars, it might be plots of land. Remember on the Unit 2 quiz, maybe on the test, it was different plots of land, and you're checking how much corn you're going to have, the yield of corn at all these places. So the experimental units could have been the plots of land. When the experimental units are humans, they are called subjects. And the specific condition being applied is called a treatment. Okay, so what we are doing is we are giving something to the experimental units or subjects, and we are looking to see how that affects them. Okay, so the explanatory variables in experiment are called the factors. I have a new microphone and a whole podcast setup, so I'm going to be playing with it and the sounds and see how it turns out. But these are called the factors of an experiment. Let me get the eraser. I was too busy mixing my audio there. Explanatory variables of an experiment are called the factors. And if there are many factors within an experiment, we call them the levels of the factors. Okay, and we have an example that will go through all that. Okay, the purpose of an experiment is to reveal the response of one variable to the changes in the other variable. And basically what we're doing is we're seeing how y changes when we change the x. And anytime we're doing an experiment, we need something called a placebo. We need to check and see if our treatment is actually working or if that's just what happens to everybody. So what we do is, a lot of the examples in this unit are with weight loss. So if you're talking about weight loss, you need to first figure out if this pill actually works. Or first you have to weigh everybody, but then to see if the pill actually works, you need one group of people that aren't taking the pill, and you need one group of people that are taking the pill. Then you can compare the two groups and see if the ones that were taking the pill, it actually worked. Okay, the people that aren't taking the actual weight loss pill, maybe we give them a placebo, which is also known as a dummy treatment. Okay, because what we're trying to do is we're trying to reveal the response. So we want to know if there is a response or not. So we can't tell if there's a response if everybody in the experiment is receiving the same treatment. Normally, placebos are, anytime we have human groups, we will have placebos. I don't think the plants are going to voluntarily grow just because they got extra water or a fake fertilizer. So placebos mostly for subjects if the experimental groups are humans, but we may have a couple here or there examples where we did use a placebo for non-subjects. Now, there's an example in the book. It says it's example 3.3, and you don't need to go to your book. I'll explain it to you. Okay. They did an experiment involving about 22,000 male physicians, and they are checking to see if taking aspirin will help reduce the risk of heart attacks. Okay. They also have found that beta-carotene use helps reduce possible cancers. So what they're going to do is they split these doctors into 4 groups, and they're going to give them different treatments, and then at the end of the study to see if there was a reduction in heart attacks. Aspirin is a blood thinner, so it helps the blood get through the heart faster, prevents the heart from having to work too hard. But when we are doing this, we have a couple of different things. Okay, the first thing are the factors. Now the factors are, let's see over here, whoops, pushed the wrong button. Okay, the factors are aspirin and beta-carotene. Okay, that's what we are going to be giving these doctors. Okay, aspirin, and I'll put BC for beta-carotene. Now the levels of the factors are going to be how much we're giving them. Okay, so the levels of the factors for the aspirin, what are the 2 choices in the chart over here? They are yes and no. Beta-carotene, the same thing. Either yes, they're taking, or no, they're not. Okay. Now the actual treatments are the combinations. So for the treatments, there are 4 treatments here. There is yes, they're taking aspirin and beta-carotene. No beta-carotene, but yes on the aspirin. No aspirin, but beta-carotene. And this one, they're not taking anything. They're just taking placebos. So the way this experiment works, the way it's described in example 3.3, is that on even number days, they take the aspirin or the placebo for the aspirin, and then on odd days, they're taking the beta-carotene or the placebo for the beta-carotene. So there are 4 treatments here. Okay, so 4 treatments. 1, 2, 3, 4. So you have 4 different experimental groups. Each one of those groups are going to be given a different treatment, or 4 different treatment groups, I guess is what you'd call it. Each one's receiving a different treatment. But make sure we know the difference. Factors are just the aspirin and the beta-carotene. Levels of the factors is the aspirin, it's either yes or no. Beta-carotene, either yes or no. And then the combinations are the treatments. So there's 4 actual treatments. Now what it says is at the end that there are 239 of the non-aspirin users had heart attacks. 139 of the people that used, the doctors that used aspirin had heart attacks. So we want to know, will taking aspirin daily help reduce your risk of heart attacks? Well, we have to look at this a little careful though, because the example was, or the experiment was using 22,000 male physicians. Okay, so it didn't talk anything about women. Physicians, they might already be health conscious already. They may know the warning signs of possible heart attacks and may have changed their diet. Maybe they do not smoke as much as the general public, so another risk of heart attack there. So based on this experiment, aspirin helps reduce the risk of heart attack in male physicians, but if we wanted to expand it over everybody, like we talked about Thursday, the inferential statistics, we would need a better sample group or a better experimental group. We need to include women. We need to include people that aren't doctors. So it is a very limited experiment, but it is an experiment, and it definitely has factors, level of factors, and treatments. Now, example 3.4, it's an observational study. There's not much to write here. It was whether or not, or somebody was doing a study to see if taking a foreign language course helps your English skills. So they looked at all the all the seniors that had taken a foreign language course sometime in high school and looked at their English scores for their college placement test or something like that. And it showed that students that had taken foreign languages scored higher on the English placement test. Now, this is just an observational study because there was no treatment imposed upon the subjects. Okay, she just grabbed data and tried to compare data. Now, one of the things we talked about in class is that even though it seemed that the test scores were improved because of taking a foreign language course, some of the thoughts we had were, well, they may have already been more intelligent. They wanted to take a foreign language class already. They already may be fluent in that other foreign language, so that's why they wanted to take the class. So this is just an observational study. Okay, there was no science to it. It was no experiment, no treatments, nothing like that. So I want to make sure you know the difference between the experiment. We have factors and we impose treatments, and just observational study where they grab existing data already. Now, experiments can give good evidence of causation. Remember that word we had back in Unit 2. Causation does not, or correlation does not mean causation, but the reason for the experiment is to show that we can show causation. Now, experiments are controlled so that they can lessen the effects of lurking variables. So in a controlled environment, we want just that treatment to cause any changes. So we said when we were dealing with R squared in Unit 2 that everything not attributable to X, or all of the, like if there were 95% of Y can be explained by X. We said that other 5% caused by lurking variables or other factors. The purpose of an experiment is to narrow those down to the point where only the X is causing the change. Okay, so experiments are controlled and lessen the effects of lurking variables. Now, the next part, comparative experiments. Okay, and a comparative experiment is really what we're going to deal with a lot in this chapter. And for a comparative experiment, we take one observation, maybe we weigh everybody. We impose a treatment, we either give them a diet pill or a placebo, and then at the end of the study, we observe again. Okay, so we take the first observation, we impose a treatment, we take a second observation to determine if there was any change caused by the treatment. So for medical experiments, oftentimes the placebo effects happen, causing the subjects to really think they are getting medication, so that's why we need a control group. Okay, the control group is always going to be the group that receives the placebo or nothing at all. So we always need a control group. And one of the things we want to try to limit is bias. And a bias is if the results turn out in favor of one way or the other based on how the experiment is set up. So bias is a design flaw which systematically favors certain outcomes. So we want to make sure that our experiments are unbiased. And we're going to look for ways to make sure they're unbiased. Okay. One of the things that is nice about this class is there are a lot of real-world examples. So one of the things I always like to point out is think about all those herbal supplements and all these workout programs and everything else. My wife forces me to do P90X with her at the beginning of each year, and then it takes me all year to gain the weight back. It's miserable. But all these programs, they always have a little note that says not verified by the FDA. Okay, so here's a, let me see if I can find it here. I had it before. Here's a little ad from something at GNC. It says, these statements have not been evaluated by the Food and Drug Administration. What happens is, let's see, right there. Okay, what happens is a lot of these supplements, they produce them, they make sure they're safe, but the FDA does not do any experiments, do any testing on it. So the FDA, Federal Drug Administration, forgot what the letters were there, okay, they sign off on these things. But a lot of these supplements, they don't want them to sign off on because I think they probably know they don't work. But those are all biased in favor of them working. I know with P90X they have infomercials, and they show these 10 or 15 really cut people, and it says in 90 days here's what they look like, here's what they look like now. But then down at the bottom it says they were locked in a cage, were only given one meal a day, they had a shake in the morning, a shake at night, some kind of other supplements here and here and here during the day. So they don't tell you that. They just say, oh, wow, look at my body just from working out. But there's a lot of other things that go into those. So you have to be kind of careful when you're watching commercials like that. Always look at the fine print if your TV can read it, because sometimes it's even so small you can't even see it. Okay, one of the things about your treatment groups is you want to make sure that nothing is by chance. So don't leave any assignment to grouping by judgment. Okay, we want all of our groups done by randomization. Okay, and in this unit, like I said, there's not a whole lot of numbers this unit. It is almost all words. So the only numbers we're going to use is a random number table, and we're going to get to that here on Monday. We'll go back over it, but I want to get to the bottom of this page. Now, what randomization is I have to randomly just select which group people go into, either the treatment group or the placebo group. So in an experiment, if I start out with subjects, I would write subjects over here, and I would split these two subjects into two groups. And to randomly split these into two groups, this is the symbol for randomization. Okay, a little arrow here. That means randomize. That means I took my subjects and I randomly put them into group 1 and group 2. After I randomly put them into group 1 and group 2, I imposed the treatment on both, and then I compared my results. So when I do this, when I use randomization, it says there's 3 aspects of randomization. First one is that groups should be similar. Okay, so when I randomize them just by chance, so all the groups should end up being similar. Okay, this shows that all the groups should be similar so that any lurking variable should be the same throughout. So any changes in one group or compared to another should be based upon the treatment. Okay, it's either treatment or chance, but because the groups were similar, the possibility of difference being attributable per chance are low since the groups were picked at random. Now on the back, okay, just do a couple parts right here. Principles of an experimental design. We're just going to do those top 3 there. Control of principles of an experimental design. First, the control of lurking variables. The second one is randomization of the experimental units. And the third one is replication. So replication is we want to have similar results. Don't worry about the numbers on here. We're going to get to that tomorrow. So principles of experimental design, we want control of lurking variables, randomization of the experimental units, and replication. We want to do this experiment over and over and over and over again and get the same results, okay, or similar results. If the results are the same, that means that treatment is probably working. Okay, so that's all I have for you right now. Hopefully only 20 minutes, that's not too bad. And see you on Monday.